It's no secret that in order for your app to be successful, the user has to run it. And for it to continue to provide value, sometimes it needs to keep running. However, this can cause problems when the user or the system puts the phone to sleep. While it might seem like a right idea to wake up the phone to do your work, there's a massive battery problem waiting to happen here. To illustrate this point, let's talk about my good friend Rado, whom you all may remember from the Android Fundamentals course. He's an avid social user and a game player, and his running applications are constantly checking scoreboards, uploading photos, and pulling down the latest hashtag crazes. But they do this even when Rado puts his phone to sleep, which means by lunch, his phone is already out of battery. Rado has to constantly recharge his phone because it suffers from sleep deprivation. That is, because these applications are constantly waking up the phone, they are eating up battery life instead of letting the phone go to sleep. Remember that Android will turn off various parts of your hardware in order to prolong battery life. First, the screen will dim, followed by it eventually turning off, and finally the CPU will go to sleep, all to save precious, precious battery life. But even in this inactive state, most apps will try to do work, and they will have to wake up the phone to do so. Now, the easiest way for your app to wake up your phone to do work is with the PowerManager.Wakelock API, which is used to keep the CPU running and prevent the screen from dimming or turning off. This allows your app to do things like wake up the phone at some future date and do some work, and then let the phone go back to sleep. But see, it's that last part that's actually the tricky one. Acquiring wake locks is really easy, but knowing when and how to release them is more problematic. There's lots of ways this could go horribly wrong. Like, what if your application takes 60 minutes instead of the expected 10 seconds to analyze some image content before uploading it to the web? Or what if the server crashes and you never get a response from your social ping and end up waiting forever? Well, the result is that phone would stay on, waiting for the content, and thus draining the battery in no time. Which is exactly why you should be using the version of Wakelock.Acquire that takes a timeout parameter. This will force the Wakelock to be released in these cases of crazy so that your app doesn't keep the phone awake until the battery is dead. But even this doesn't solve the problem completely. What should you set the timeout value to be in these cases? And how long should you wait after a failure before using a Wakelock to try again? The right solution to this might be to use inexact timers, which allow you to schedule work for some future date. But if the system detects that it could occur sooner or later in order to conserve battery life, then it'll wait for that time to do that work. For example, if another process has woken up the phone, your app might wait to be woken up with that group of processes rather than happening 10 seconds sooner like it was originally scheduled. And in reality, there's a whole group of situations that might be better to do battery-intensive work. For example, when the phone is charging or connected to Wi-Fi or already woken up by another process. If any of your work can be deferred to a future date when these conditions might be ideal, then you can help improve battery life significantly. And this is exactly what the Job Scheduler API is for. See, this API is perfect for scheduling some future work to occur in a battery-efficient manner. For example, any non-user-facing work, waiting until the unit is plugged in, waiting until you're on Wi-Fi, or batching a bunch of tasks to occur together at the same time. Basically, with one simple API, you can get all that scheduling for free. So let's take a look at this API in action.